In this lesson, we shall look at Mathematics 1B, our Math 141. We shall be looking at the Maclaurin series for this particular expression. So to look at the Maclaurin series for this particular expression, as you see that it is the Maclaurin series. So what we're going to do is we'll go back to part 7 for this cosine of t squared, 0 to x. Going back to part 7. And then it is exactly this one here. It's exactly this one. Right. Now, because it is exactly this one, the answer is already there. Right. So how do we do this? So we'll have to remember a couple of things here. To do this one, you need to start by saying you have the integral of 0 to x, then you have the cosine of t squared, and then you have dt. Right. So now you need to remember. So now these are the things you need to know. Right. So you need to have the formulas for the following. You need to have the formulas for the Maclaurin series of the cosine. Right, Maclaurin series of the cosine. Right. So this is what you're given. Right. So we have the following. So which means that if you have the cosine x series, right, need to remember that. Let's write here first. Whenever you have cosine x, it is the same as what? 1 minus x squared over 2 factorial plus x to the 4th power over 4 factorial minus x to the 6th power over 6 factorial, and so on. But simultaneously, cosine x is exactly the same as what? N equals 0. Which is 2n factorial. So you already have this. So you can use either any of this for the cosine series. Right. So at this point, then you think and reason of this very carefully. So what you then ought to do is to take this into account. Okay, one way to do this is very short. You can look at the integral from 0 to x. What is cosine? Cosine is this series. So it is the integral from n equals 0. Then we have minus 1 to the n, or minus 1 to the k. And then you divide by 2k factorial. Then we have x. Okay, in this case, there is not x, but there is what? There is t squared. So you're going to do t squared. Then you have 2n. And you have dt like this, giving us the integral from 0 to x of the infinite series. So you're just putting this one because you can write it like this, but you can put it like that. Because it's already, answer is already in sigma notation. So you have minus 1 to the k, then you have t. This one is going to be 2 times 4 here. Okay, why are we dividing by the 2k factorial? It is the formula. It is exactly the formula for the cosine. So there are two of them that you need to learn for purposes of the exam. Right, so it's this one, but also you need to remember the sign. You need to remember the sign. Right, so for example, you need to remember that whenever you have sin x, right, we're going on. So so you have this, n equals 0, to n plus 1, and then this x to the power 2n plus 1. So that they're in the end. Okay, there are two series. Now, for the sine, these are the formulas. These are the Maclaurin series. We mean Maclaurin. Maclaurin series. But now, in this case, you have 2 times 2n, which is 4n. Because the formula has 2n factorial and also this. But you can look at the series expansion of the sign. So if you put 0 here, it becomes exactly x minus x cubed over 3 factorial. And then you have plus x to the power 5 or 5 factorial. So this one, you have 2 times 2n. Because if it's x, then it's x to the n. But here it's t squared. So wherever there is x, you put t squared. And 2 times 2n is 4n. But this thing is divided by what? It is divided by 2k factorial. So now, we're going to do the integral of this, which is n equals 0. Minus 1 to the k, 2k factorial. T to the, okay, this is k. Call this k. You can just use the symbol k for our purpose. N and k can use k because the questions are using k. Right, so you can use just k here. As much as you can use n. You can use k here. You can use k there, which is 4k plus 1 divided by 4k plus 1. Then you have that, because you have found the what? You have found the integral of this. So when you're finding the integral, you only deal with the t, because it's dt. You only deal with the t. Integrating from 0 to x, which is this. And then you put k here. Which is to the k, to k factorial, for k plus 1 divided by 4k plus 1. And then if you substitute a 0, then you substitute this one, then minus 0. Substitute x, and then you get this. But now this is already the answer. K equals 0. Just rearrange everything, minus 1 to the k. Then you have x to the power 4k plus 1. You divide everything by 4k plus 1, 2k factorial for all x. Okay, this is the answer. Any question? Think about it. Make sure you understand this, because I'm doing this because it's in the. If we do this, it's the same as we've done that on the series. Okay, any question about this one? Any question about this one? Okay. Sin x has looks the same as the cosine, but it has 2k plus 1. This one cosine has minus 1 to the power k because they both alternate, and x to the power 2k. But the sine has 2k plus 1, and the power of x is also 2k plus 1 for the sine. And these are the Maclaurin series for the sine and the cosine, which are very, very popular. Okay, so you expect to know this because they can bring cosine or the sine in the test. Okay, so take note of that. Let's move on to the next one. Now let us do this one. Let us do this one. Now to do this one, it's already that. But clearly this one, you just need to know one thing. You need to know this one. Okay, what is this one? Okay, good. How did you obtain the 2k plus 1? Okay, the 4k plus 1, how did you obtain it? Okay, we obtained the 4k plus 1 because if you need to integrate t to the power 4k. And to integrate t to the power 4k, you use the formula. You use the formula x to the power n dx. What is the integral of x to the power n dx? Is 1 over n plus 1 x to the power n plus 1 plus c. Okay? This is the formula. X to the power n is x to the power n plus 1 divided by n plus 1 plus c. But we're adding c here because there are no limits of integration. So here it is t to the power 4k. And then if you add 1, is t to the 4k plus 1, and then divided by 4k plus 1. So because we're integrating the t to the power 4k, so if we integrate the x to the power n, what do we do? X to the power n. You say x to the power n plus 1 and then divide by n plus 1. So here is the same. You are only looking at the t because it's dt. These other things are constants. So t to the power 4k, and then t to the power 4k plus 1 divided by 4k plus 1. And then from 0 to x. And then you do that, which is exactly x here for all x. For all x. Any question? Make sure you understand these things because this one is already in the test, this question. Very likely, this one is already in the test. It is already in the test. Next. Next thing you're going to look at, okay. Let's look at this one. To do this one, you'll have to look at the fact that the e to the t is the same as like e to the x. Okay, same thing. So this one, you're going to take it from k equals 0 to infinity. X to the power n divided by n factorial. T to the power n divided by n factorial. N equals 0 to infinity. Which means that you have to do 0 to x, 1 minus e to the t divided by t. So to do this one, you have to think about this, but look at the answer to this. Look at the answer to this, and then think very carefully about it and realize that what you need to do is to consider this. So 1 minus, in the place of e to the power t, then you're going to write the summation e to the t is just t to the n over n factorial from n equals 0. You divide by t, and then there is a dt here. So this becomes the integral from 0 to x. 1 minus. You can just write out some of the terms here. So if you write out some of the terms, what then are you able to achieve here? When n is 0, you have 1 plus 1 plus t over 1 factorial. T squared over 2 factorial. T cubed over 3 factorial. T4 over 4 factorial. Divided by t dt. 0 to x. Subtract. So, okay, yeah. So you have the t, you have the 3 factorial here. And then t to the 4 factorial. And so on dt. At this point, you divide through by the t. Divide through by the t, it's going to be t divided by t, it's a 1. T squared divided by t, it's t. You divide by t, it's t squared. Divide by t, t to the third. Plus dot, dot, dot. Dt. So we can start from here, which is the integral from 0 to x. Then you integrate this. If you integrate that, what is the integral of the 1? It is just t. The integral of this one is going to be t squared over 2, which is 2 times 2 factorial. The integral of this one is going to be t cubed over 3. There's 3 factorial. The integral of the next one, and so on. And then there is, yeah, we found the integral, so please remove we'll remove the integral sign, because we've already found the integral. We've already found the integral, and then we integrate from 0 to x. Right, if you put the x there, it's going to become what? It's going to become minus, in the place of x you put, so it's going to be x minus x squared over 2 factorial. Okay, this is all plus within the parentheses here. X cubed over 3 factorial. And so on. So, this is what you have. So now, if you check this here, this becomes the answer. So if the answer is minus x plus x squared over 2 factorial, x cubed over 3 factorial, and so on, which is exactly the same as what? So this one, you want to write it like this. So the way to write like this, there's already a negative here. This negative is already there. So you can write it as a summation. And then you can write from k equals 1 to infinity. Then there's already this minus. Then you have x to the power k, because it starts from 1, 2, 3, and so on. And the denominator is divided by k times k factorial, because you put 1 here, and then next you put 2 factorial, then you put 3 factorial, and so on. And this is true for all x. Any question about this one? Okay, the giveaway to this was that there is 1 minus e in the top. The 1 minus e in the top, you see the 1 was not there anymore. This was one thing. So it meant that you had to substitute the integral of the e to the t expression, which is the summation of t to the n divided by n factorial from 0 to infinity. 0 to infinity. Any question about this one? Okay, you need to make sure you understand this, because this is already the test. This is already the test. Right, this is already the test. 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 Think about it and make sure you understand it. Right. Think about it and make sure you understand it. Right. Next. Let us do this one. Okay. Yes. You need to memorize the formula. You need to memorize the formula. So, what formula are you supposed to memorize? What formula are you supposed to memorize? Here, you need to memorize the formula for the e, this e to the t. You need to memorize the formula of e to the t. E to the t is this one. And you need to memorize it. It is exactly this one. E to the t is this one, and you need to memorize it. Right, so you need to memorize it. E to the t. Like the other things I said you need to memorize, what are they? There are two. You need to also memorize cosine x. Cosine x is -1 to, it's a formula, -1 to the k divided by 2k factorial. It's always divided by 2k factorial. Is the formula for the cosine x. But you can also write it as 1 if you memorize this one, or you can say 1 minus x squared over 2 factorial plus x to the 4th power over 4 factorial minus x to the 6th power over 6 factorial. Then what do you have here? So we continue. We continue. You need to memorize the formula for sine. What about the sine? Sine you need to divide by 2k plus 1 factorial. -1 to the k, x to the power 2k plus 1. So sine has 2k plus 1 divided by 2k plus 1 factorial. That is the formula for the sine. But for sine x, when you write out, when you put k equals 0 here, you get x. Next, you put x cubed, you get minus x cubed over 3 factorial, plus x to the 5th power over 5 factorial, and so on and so forth. And so on and so forth. And so on and so forth. Right. So what are you supposed to memorize? You must memorize that cosine x is -1, summation of -1 to the power k over 2k factorial. So you need to write it down, this one, in your scribbler. But also you can write it out in expanded form, which is 1 minus x squared over 2 factorial plus x to the 4th power 4 factorial minus x to the 6th power over 6 factorial, and so on. Right. So the sine x is x minus x cubed over 3 factorial plus x to the 5th power over 5 factorial, and so on. So this is what you have. Obviously, we're going to send you this recording. What are you supposed to memorize here? You must memorize the formula of e to the power t. What is e to the power t? Or e to the power x? It is t to the n over n factorial, the summation from 0 to infinity. You must memorize this one, because if you know the e to the t, then here you can just solve this question. Okay, because you need to substitute the formula for e to the t, and then you get the answer. Right, so then this will be the answer. Now, to do this one, you need to do the formula for the ln. So now this one, we have the ln t divided by t minus 1. Okay, to do this one, you need to do the formula for the ln. Right, what is the formula for the ln? Right, so you need to do the formula for the ln, and the formula for the ln is the same as, you can do 1 over t. What becomes the formula of 1 over t? Okay, so you can look at that as the formula, for example, of t to the -1. And then you need to find the series expansion of ln t. Series expansion for ln x. Okay. Okay, we here? All right. Okay, now if you forget these things, what you do? You'll get marks for this. If you forget these things, you write in your book. you let f of t be t. You forget the series formula because here you need to use the series formula for ln t. Okay, so you let f of t be ln t. Then you do the derivative, which is 1 over t. The second derivative, minus 1 over t squared. The third derivative, which is 2 over t cubed. The fourth derivative, the fifth derivative. Okay, then next you're going to do the substitution. Okay, then now you're going to have to do this particular series at a given point. Right. You're going to have to do this particular series at a given point. Right, at a given point. Right, you need to do these at a given point. Okay. All right. So look at these then and reason, but reason very, very cautiously. Okay, reason very, very cautiously. Right. Reason very, very carefully. Reason extra, extra carefully. Okay, because I was then saying this become the derivatives of the ln. And then now these you can evaluate at certain points. Okay. Right, so when you have this, there are certain things obviously you would have to remember here in this case. It would then be the fact that how would you determine the actual series for this particular expression? How do you determine the series expansion for this particular expression? Right. Okay, just 1 second. There's something I would like to say here. Right. So you'd have the following. Right, 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 right. Right, 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 right. Okay. That's what you're getting, but there's something I need to mention about the fact that in general, the you have to look at the fact that this from 0, ln 0 is undefined. So, which means therefore you'd have to do a couple of changes for this. Right, you need to do a couple of changes because at 0, this ln t is undefined. But, and then what you ought to do becomes exactly the following. There's certain knowledge you have about this series, like the ln of 1 plus x. It is x squared over 2 x cubed over 3 and so on, which is the series k equals 1, k equals 1 to infinity, minus 1 to the power k plus 1. And then you have x to the power k, yeah, divided by k for minus 1 less than x less equal to 1. Okay. So you know the ln of 1 plus x. All right. So then if you know the ln of 1 plus x, the question then is what can you do with that? Because you already know that. And this therefore tends to actually resemble that. So if you already know this, you can then be in a position to use that knowledge. All right, you can then be in a position to actually use that knowledge to actually achieve the answer to this. Right, you can use that knowledge to achieve the actual answer to that. Now, if then you have that, this is the ln of t. And this ln of t, it does not have, ln t does not have an explicit series. But the series we know is that of 1 plus x, so you can actually look at the ln of 1 plus t, which is exactly something you know. Now with this, then you think, you reason, but very, very carefully. And therefore realize that you can do something about this. Simultaneously, for instance, if this is the case, if you let u be ln t, okay, this is improper at this point. So you have du, which equals 1 over t dt. That is something you can actually simultaneously be able to explore, which means that t du is dt. And then you have t minus 1 dt. So the u becomes, the ln t becomes u. dt becomes t du. Like that. Right. And so What then would that exactly be here? There is something I want to say here that is going to be very helpful in helping us to actually achieve the this particular question's result that we want. So you're going to do this one, and then you're going to have the 1 plus x. So you then have, and then t minus 1 dt. Right. Right. So you can have exactly that. Okay. So the couple of things obviously that you need to do here, if you have this, you can let, which is going to simplify things. You can let right budget space. So we can let this one be a variable. So that is what we're going to do. Let me just go straight to the point. Okay, consider these two series, or the series expansion of the ln. So we're going to have the integral. So this one is improper. In principle, what you need to do is to use our usual stuff. So you're going to use 0 plus epsilon, take the limit, because it's undefined at 0. So you have the limit as epsilon approaches 0 from the right. The integral of like 0 plus epsilon, 1 plus x, the ln of t divided by t minus 1 dt. Then you take the limit as epsilon approaches 0 from the right. Next, what you do here, you're going to have, okay. Okay. You can let something here. In this case, if you let 1 plus x be t, which means that t is going to be, which means that x is going to be t minus 1. So that you have ln t, the summation of minus 1 to the power k plus 1, and then the x becomes t minus 1 to the power k divided by k. Okay, that is the answer. All right. So then you can come here and then say, okay, I can write like that, but I feel that maybe I'm making it too complicated. So let's first see if there's going to be a problem here. Formally, that we'll have to put the limit, but I feel that maybe I'm writing too many things. So you can do 0 to 1 plus x, and then what is the ln? This is the ln t. The ln t is the infinite series. K equals 1. Minus 1 to the k plus 1. T minus 1 to the k divided by k. And then you divide everything by t minus 1 dt. Okay, and then this is going to be the integral from 0 to 1 plus x. The infinite series from k equals 1 minus 1 to the k plus 1 t minus 1. Okay, this one you can write it as k minus 1 because this is to the power 1, so you subtract the powers. This is out of k dt. If then integrate this, which is minus 1 to the k plus 1 divided by k. And then if you integrate these, t minus 1, you add 1. Minus 1, you add 1, but also you add 1. Like this. This integration is done from 0 to 1 plus x. So let us check what you're going to have here. So this is going to become the integral k equals 1 minus 1 to the power k plus 1 t minus 1 to the k, like this. And then you are integrating from 0 to 1 plus x. Okay, so you need to memorize the ln of 1 plus x because ln x does not have a series. It does not have a Maclaurin series. All right, so you get this. What then can you see as the answer to this? So wherever there is x, wherever there is t, you put the x minus 1. All right, so it's going to become the summation from k equals 1 minus 1 to the k. You put here, if you put in the place of t, you put 1 plus x. It's just going to be x. Okay. And then you have the x to the power k divided by k. Like that. Divided by k, like that. So let's see what you're getting. Then that's when you substitute the 1 plus x, and then you put 0 in the place of t. If you put 0, it's just going to be the minus 1 to the power. So you're going to have like minus 1 to the power k plus 1, and then multiplied by minus 1 to the power k. Because wherever there is t, you put 0. And therefore, this is minus 1 to the power 2k plus 1. And therefore, this would just be a minus 1. This will just be a minus 1. Right, so it gives us something of that nature. But then now you can perform a transformation. Really can perform a, yeah, because there's a k and there's a k, so this is going to be k squared. When it's k squared and hence a square, but you'd have to actually do a little transformation. If this is to start from 0, right? If it is to start from 0, then you'd have the following. Right, if it is to start from 0, then you can start and put k minus 1, 0, the summation. Right, you can put infinite series. And then minus 1 to the power. So you have exactly that. So if you start from 0, it is going to be, the first one is going to be, if you start from 1, it's going to be 1 squared to the power 1. So you can change this and start from 1. Okay, look at this. This is very important. So you can start from 1. You can start from 0. But if you start from 0, then you must add a 1. The k plus 1 to the power k. Okay, when you start from 0, which is when you start from the 0, it will still be the 1 squared here. Okay, it will still be the 1 squared because it's k squared. But now you're starting from 1. If you start from 1, then it becomes 1 squared. If you substitute in the place of k, you put 1 squared. But if you start from 0, you'd have 0 plus 1, which is also 1 squared. So we can perceive this as being very, very equivalent in a way. Yeah, we can perceive these two sums is equivalent. So it takes us to that. So this is how you can do the Maclaurin series for this one. Think about it, but it requires you to know, to memorize this one. Memorize the ln of 1 plus x, because there's no Maclaurin series for ln t, but for ln of 1 plus x, it is x minus x squared over 2 factorial. But there are no factorials excused here. There's x minus x squared over 2 plus x cubed over 3 and so on. But you can write it as minus 1 because it alternates. It's minus 1 to the power k plus 1 x to the power k divided by k from 1 to infinity. You need to memorize this one. But again, it is such that it converges for this. It converges for this. Modulus of x less than 1. Think about it and make sure you understand it. Obviously, you're going to send your recording and you can pass through it. Okay, we did this Taylor polynomial yesterday. You just need to remember the Taylor formula. This one we did yesterday. The Taylor polynomial of this fourth root. And then also we did the find the first 3 terms in the appropriate Taylor polynomial for the sine 44. We did. We did. Use the nth order Maclaurin polynomial for this to estimate that, yeah? Can always do that. So, okay, let's look at these ones. We are back to these problems. So, these problems now are the ones for revision. Okay. Yeah, because you are good. We've done most of them. Okay, we've done most of them. Like this one we did. This sign of ln x we did. This one is integrating factor. Integrating factors. Method of integrating factors. Okay, I'll just comment on this cosh. We've done it in the cosh. The cosh, we need to remember what? For the cosh, you need to remember e to the power x. E to the power x is the same as what? You need to memorize this one. From k equals 0 to infinity, x to the power k divided by k factorial. So e to the power x minus e to the minus x. What is e to the power x? So it's exactly x over 1 factorial, x squared over 2 factorial. Okay, but we must start from 0. We need to start from 0. For the cosh, it's plus here. It's plus there. Okay, but now then you need to use that. You start from 0. You start from 0, it becomes 1 x over 1 factorial, x squared over 2 factorial, x cubed over 3 factorial, and so on. And then we have 1 minus x over 1 factorial, x squared over 2 factorial, x cubed over 3 factorial. Okay, when you do e to the x, then you do e to the minus x, because it's e to the minus x for the cosh. Can do the hyperbolic side. It means that you're going to have k equals 0. Then in wherever there is x, you put minus x. So it's going to be minus 1 to the power k, x to the power k divided by that. Because you just put the minus here, but it's to the power k. So in other words, if you do e to the minus x, you do the infinite series like this. It's minus 1 to the power k over k factorial, which is the cosh of x. Right, so you have 1 plus 1, which is 2. Next, this x minus x, the cube minus cube. So you're going to be left with x squared. Let's just add one more. X to the 4th over 4 factorial plus x to the 4th over 4 factorial, which is 2 over 2 factorial. 2x to the 4th over 4 factorial. And then minus. So in the end, then you have 1 plus x squared over 2 factorial. X to the 4th over 4 factorial. So then you have k0, which is x to the power 2k. That's what we have. Okay, this one we did. We did, but I'm just playing around with it. The cosh. We did. And then this one will be k, because it's 2, 2, 2, these things. So you can write like, you remember it was like 2k over, then you divide by 2k factorial. Why do you divide by 2k factorial? Because it is like the 2k is here. And this is what we have. So that is what we have. Okay, so this is the series in powers of x. Yeah. So we've done this, and then I'm gonna remind you now. Yeah. This we've already done. Okay, for the integrating factors. Okay, let's check the 2K. How did you get 2K? Because it is 2468. 2468. So if these things are 2468, is 2 times something. It's 2 times K. Because it's 2468. It's going to be 2K. It's going to be actually 2K because it is 2468. All right. So 2K is for the even numbers. 2K in mathematics is for even numbers. So these things are even, 2468. But if it is odd numbers, it becomes 2K plus 1, odd. Okay, good. Right, so that's what you're getting. I wanted to mention this one in passing. This one it did last time, but it was integrating factors. So you do dy dx plus p y equals q. Okay. Divide and have y primed. Divide by x, and then you have the sine of ln x. Okay. The p of x, we have the integral of this. Which is e to the minus the ln of this x. 1 over x is the integrating factor. Then you use the integrating factor. We did this yesterday, last time. So this one is separation of variables. Okay, because the test is gonna, hey, what you can see, what is likely to shock you is that when you walk in, you will see this test, this one. Telling you. That is what might shock you. So if you have 1 over x, then you remember, yeah, I don't want to waste a lot of the time there. Because we did this now. This one is separation of variables. Separation of variables means what? Means you cross multiply. And then you have this one, e to the y, dt over y, x squared. Yeah, there's a mistake here. There's a mistake in the question. It must be dx. It must be dx. But they typed dt. But this must be x. So that you're dealing into dy dx, which is e to the y divided by y x squared minus 4. Okay, let's call it today. Thank you so much. Please watch the videos. I'm sending the recording of this one as well. Thank you. Memorize all the series for... Okay, let me write the things you need to memorize. Because I don't want you to leave. We should have done yesterday, but yeah, I fell asleep. So this one for e to the x, you need to memorize this. So memorize e to the x, k to 0, x to the k, divided by k factorial. Memorize cos x. Okay, also memorize 1 over 1 minus x, which is 1 plus x squared plus ... which equals this one, x to the n, x to the k, k0 modulus this one. Memorize cosine x, which is the infinite series of minus 1 to the power k, x to the 2k over 2k. You always divide by 2k. K equals 0 to infinity. Memorize the sign. Memorize the sign of x, which is... Okay, to memorize the sign, you need to remember the cos, that it's 2k, and then the sign is going to be what? The sign is actually exactly 2k plus 1 divided by 2k plus 1 factorial. So you must memorize that. The fact that the cosine is x to the power 2k over that. Where are you going to apply it? You want to apply it when you have some problems, when you have questions. Where do you apply the e to the power x and the 1 over 1 minus x when you are dealing with Maclaurin series? Right, when you're dealing with Maclaurin series. How? When you're dealing with Maclaurin series, like when they say find the Maclaurin series of sine x over x, you must remember this one. And then you just divide this one by x, you know. So those are the kinds of things where you need to remember this. Okay, yeah, I think it's fine, but I'm gonna text you on WhatsApp. Just I think if because I want these things. I want us to get very good marks in this module. So yeah, okay. But I must thank you for joining us. It was awesome with this discussion. I think I'm gonna check with you on WhatsApp. Okay, for now, take care. Goodbye.